All right, finishing up, going through I think I have 3 examples to run through quickly here. So for the line, 2x plus 5y equals 16. So keep in mind that's standard form. Determine the equation of a line in general, parametric, and symmetric. Remember general form, alternate word for vector. So for each of these forms, we need a point, and we need a direction vector. So that's what you got to keep in the back of your head when you're finding these 3 forms. So when we look at 2x plus 5y equals 16, what can we get out of it? What can we get out of it? And the question, or the answer to that is, first of all, you can get a normal vector, which we know is 2, 5.
I'm sorry, Sister Ava here.
Sorry about that, 2, 5. So what does that tell me then? Well, we already said that a direction vector and a normal vector are perpendicular to each other. So that means by flipping the coordinates, 5, 2, making one of them negative, and again, it doesn't matter which one, you end up with a direction vector. So that means that we have a direction vector, which means we have one of the 2 criteria. Next, we need to find a point. How do you find a point? And this is often, students overlook the easy or the obvious here. For that equation, 2x plus 5y equals 16, if the point is on the line, that means that we know an x and y value that satisfy this relationship or equation. So keep it easy. I know that 2 times 8 is 16, so if I look at it as the left side, and I know I want the right side, or the right side's equal to 16. 2 times 8 is 16. I'll make a y a 0. I have a 16. So therefore, the coordinate's 8, 0. And you do any combination you want here, but don't make it easy. If you can make one of them 0, please make one of them 0. It speeds up the process. So all you need to do is find a point that satisfies the conditions of that equation. So we have all the information. So here we go. We run through the vector form. Vector xy equals, so 8, 0 plus t, and direction vector was negative 5, 2. So there's vector form. Parametric form of this line. X would equal 8 minus 5t. Y would equal 2t. All right. And symmetric form. X minus 8 over negative 5 equals y, and I'll emphasize it here, y minus 0. It's not needed. Y minus 0 over 2. So there are your 3 forms. So your vector form, your parametric, and your symmetric. So there's the answer. All done. Okay, so there's 2 components here. You're in the first stage, you're getting the information you need. That's stage 1. And then stage 2 is doing what you've practiced already, given all that information. All right. Okay, now the distance from a point to a line. So in this one, I'm going to show you or demonstrate on how that equation is developed. All right, so when you're finding distance from a point to a line, so this is in 2 space still. We'll talk about 3 space a little bit later on. We're looking for the distance from point Q to the line AB, and we're looking at the shortest distance here. So we're looking at, we're looking at the distance from any point on the line, P naught, to point Q. So we're looking at this distance here. All right, so how do you determine that particular value? Well, we're going to go back to something that we learned in the previous unit. So we use, in the vectors course, we use capital D for distance. And we want to know a magnitude. We're looking for a length here. So that means we're going to be looking for the positive value, or the magnitude of. And what we're looking for really is this vector, P naught Q. We want to find the shadow, or the component, or projection onto the normal vector. So what we're really looking for is the projection of the vector P naught Q onto the vector N. Oops, can't draw my N's. Onto the normal vector. All right, and that would give us the distance from the point to the line. All right, so Once you have that, things start to clean up, and I'll show you how the formula is then derived. So the projection formula again would be P naught Q dot the normal multiplied by the vector itself, the normal vector, and that's divided by the magnitude of the normal squared. So that's going back. That should be on your cheat sheet, by the way, the projection formula. So if it's not, please make sure you go back and add that. How do we clean this up a little bit? I'm going to use distributive law because it's a dot product. We're multiplying. So when you do that, you end up with P naught Q dot the normal, and then you would end up with the normal dot the normal over the magnitude of the normal squared. Now any vector that is multiplied by itself ends up being the magnitude of itself. So n dot n becomes magnitude of n. And now we can do some simplification. So that our final formula then, and this is what needs to get on your formula sheet, is P naught Q dot the normal over the magnitude of the normal. And I'm going to take it one step further because we know what is P naught Q dot n. So what is the numerator equal to? What's it equal to? Well, it's equal to the standard equation. So we would end up with n1 x plus n2 y plus c divided by the magnitude of the normal, which is this just n1 squared plus n2 squared square rooted. So that's probably, of all the formulas or all the forms here, this is probably the one you're going to want. Again, you don't need to reprove something for me on the test. I'm not asking for you to regurgitate stuff. It's a math course, not another form of course that I won't pick on since you're watching this online. So there's the formula to find the distance from a point. So distance of a point to a line. All right. And I believe I have an example of that. Yes, I do. And we'll go through that quickly to finish this up. So determine the distance between the point 83 and that line. So it's just a matter of looking at your cheat sheet. I'm not going to drag it out any more than it has to be. It's more or less understanding what you are asked or what you're given and simply plugging and chugging. At this point in time, we're not doing a whole lot of connecting. Still doing base skills at this point. So the normal. Well, we know all you're doing is plugging in the values here. So it's going to be 2 multiplied by the x value, 8. And I'm getting my x and y value from the given point. That's where that information is coming from. Plus 5 times the 3, and then minus 16. So that's your numerator. And then it would be 2 squared plus 5 squared, square rooted in the denominator. So we're looking at 16 plus 15 minus 16. And I do like when it works like that. And 25 and 4 is 29. Remember, those signs are absolute symbols, so we're looking for the absolute value here. 16s cancel out. So the answer would be 15 over root 29 units. So therefore, point, what did we call it originally? Point Q. Point Q is 15 over root 29 units from the line. That's it. No catches, no other steps. It's just a straight, here's the formula. This is how you use it. All right. Here's the assigned homework with this section. Make sure you go, make sure you understand the note. If there's any questions, let me know. And then please make sure you go through and do the homework questions because there's some variations on this and stuff that you'd probably see or more likely to see on a test. So anyhow, good luck. And if you have any questions, you know where to find me.